Hi guys and girls, and welcome back. Yeah, I can't sleep. I can't stop and I can't think because there's something going around in my mind. I want to know why that low power doesn't work. And I took RV5 out, which is the low power potentiometer, and it reads a little bit over what it should, but it's okay. It's not open or damaged. So if we go to the manual, this is the manual for the Rotel RVC 240, but it uses the 134 board, the 134 OA AOX board, the same as what's in the Fidelity. The Fidelity uses this circuit, so we're good. Now, here's the high-low power attenuator here. You got your ground there, which is in the middle. When it's in off, when the attenuation's off, if you follow the line up here, this has been redrawn, this circuit, and it's very understandable. It goes right across, and it goes to C42, which is 10 nanofarad. That's where our low power, that's how our high power. Now, if we flick the switch to on, which is low power, and we move to here, well, what we're doing, we're going through this resistor. We've got R5, we're going through this resistor and R5. So what's happening is what we're doing is we're breaking it and sending it to there. So that's how it's working. So basically what we need to do is look at we've looked at RV5, and that's 300 ohms. It comes in about just under 400 on the component, but that's okay. Now we've got R119 rather, which is 270 ohms. Now that is in the direct path, so I've got a feeling it won't be that, because that's your pre-driver, I think, 2SC 1846. I think that's your pre-driver. I'm not sure, but I think that's your pre-driver. It could even be your output. Let's just have a look. It could be your final. I'm not completely sure. But yeah, there's your antenna out there. It is, that's your final. That's your final, and we know the final's working. So what we're gonna do, guys, we're gonna go to bench one, and what we'll do, we'll change. We'll take we'll take R119 out, and we'll test it, and we'll see where we go from there. Right. So Scraps has just sat there and he doesn't realise he's got to move. Move, son. Move. Oh, you have moved. Good boy. That's all right. All right, lad. All right. You have moved. Right. So what we'll do next, if there's enough, we're only going to use camera. Hang on. Right, so we'll come in a little bit. We'll come in a little bit if we can with the zoomer. Well, don't you start moaning, Scraps, because you've been out and you've had everything. Yeah, Christine got her 70 quid back for the vet. Not because my daughter got on to me, because I owed it and I believe in paying what I owe anyway. But she got it back, so I sent it to my daughter, because I don't trust Christine with my bank card, as we all know. So let's take this resistor out. I've already desoldered it, sucked it a little bit, but there we go. Try and get this side here. Now we should just be able to push that out. One side gone, and that should go. There you go. So if I tip this upside down now, and it's very hard to get into there. I'll tell you what, putting the resistor back in is going to be a pain. But I've got a feeling it's got to be around this somewhere. There you go. This could be open, it might not be. But I took a reading off that other component, of the same component, that scrap area, and I got two different readings. So I got different readings when I checked. And I know the low power worked on that area because I repaired it. It was 270 ohms. That's not our problem. Yeah, that's not our problem, guys. The problem isn't there. That's not the problem. That's not the problem, so he can go back in. He's not the problem. That's not the problem, guys. So what is it then? Move these wires out of the way. I mean, let's move this blue wire out of the way. See, these are your what connect to your low power. I was a bit convinced on there, guys. Obviously I was wrong. It wasn't the problem. There you go, it's back in. So we need to look a bit further. But that's what electronics is all about, guys. It's, where's the bleeding solder? There it is. That's what electronics is all about, really. Oh, there's some there. There's some here. That's what it's all about, really, guys, is looking for the problems. There's a broken capacitor that goes to the chassis in this as well, needs to be attended to. Right, so what we're going to do next, we're going to solder that back in there. I think I've just found it. I think we've got a crack in the board there, guys, but I don't fucking know. Looks like we've got a crack. Not in there, we haven't. But I was looking around here. I don't know. Let's put it on continuity. No. Looks like it, but it's not. It's just shit really, guys. So basically when I go to here, so I've got nothing there. If I flick the switch, 250. Now if we go to the, if we get the Harrier, it's exactly the same radio, it's exactly the same chassis. Right, so we want to look at one, two, three. That's right. And we want to check. There we go. See, this is the Harrier. I've lost where I was looking at now. Lost where I was fucking looking. Them 3 wires there. There you are. Now if we go to this one. Oh, hang on, I'm on diode. We'll go to this one here, which is on a resistor. 83 ohms. Now if we go to the switches, that's Delta tune, I think. Can't remember what that switch does. Let's see which one does the high-low power. I think the one that does the high-low power, there's the high-low power there. There's the orange, blue and grey. It's this fucker here. It's that middle one there, so it's that one. Oh, that one there. So if I put that there, go back to where we were looking, which was here. And see. That changes. That's gone to 84. Now it's gone to 6. It's jumping about a bit, but now if we go to the next one, because the middle one's ground. Hang on. Flick that down, goes to 5K, 4K, and flick it back up, goes to 84. So, and I'm pretty sure ours isn't doing that. I'm pretty sure our switch is fucked. Oh, hang on, oops. So we'll do exactly the same test. That's not doing nothing. Now if we go to the other side, that's 30. That one is 138. That one is. If we go to this one, nothing. So, if I turn the radio upside down, so we're getting, so we've even got a broken wire, which we'll check. That's high power, and it's not switching down to low power. So we'll check the wires. That's okay. Yeah. Yeah. Check the blue one. See, this has got to be right before I do the builder, really. That's right, so the wires are okay. So if I disconnect, so if I now go to the switch, so according to that the switch is working. But it's shorted out there. That's ground. Right. What we'll do, guys, we'll change the wires to the top of the switch. Right, so what we'll do, we'll change the wires. I cut the wires here, not cut them, cut them. I cut the connect the, what do you call it, the cable tie off so I can get to the wire easy. Right, so it could be just a switch that's worn. It could be short even. Let's take this one off here. There you go. Get this grey one. There we go. grey one on the top of there. See, we could even have a bad switch. I can't see why though, but there again it could be a short. But we're not using this switch anyway, so we're not using it anyway, but let's plug the radio back into the instrument, into the power supply, and see. Let's get my mic. I did have a dummy microphone plug, but I don't know where it went. That's high power. That's still high power. So changing the power level, changing that made no difference. Changing the switch, that's a low power level. No, that's not making any difference. So what we'll do, we'll take the wires off the switch, turn the radio off first, take the wires off the switch, and just leave the ground on. See if we Right, so connect the ground. Nope. Nope. So it's not the switch. So disconnect that from there. So it's not the switch. Oh. Doing that rules out the switch. So basically, that's not the, so basically that's not the issue. Now what's numbers that transistor there? Now that transistor there is our pre-transistor, and the only other one doesn't go anywhere near it. It could be have a look at this one. Has that got one of them fucking filters in it? See, this has got a fucking filter in it. The area hasn't. I wonder if that's been put in by some fucker. And that's. I wonder if that's killing our low power. try that. That could be killing our low power. It's possible, you know, it's... I don't think that's the issue. Don't think that's the issue, but you've got to check. No. That ain't it. To be honest, I never thought it was, I just wanted to check. Put soldering back in. See, we've got a piece of fucking cable going, let's just lift him out a minute. We've got a fucking wire shorting out there. That could be causing it. That's it. So let's get back onto the so I think well, since I just cleared that there, still not making any difference. Not making any fucking difference, guys. No, low power. Yeah. So we should. None of these have been fucked to hours at the front, have they? I mean, that's pulling a bit of current now, 'cause that's dimming. That's dimming slightly when I key it up. So so let's turn that off. Let's turn that off. Now, so basically what we've got, guys, what we've got really, we've got a fucking short somewhere. So we'll go there. That's okay. We'll flick that. Still got a short there. I shouldn't have nothing there now. And we've got nothing there now on that one, and that's right. Now when I flick the switch, show a short. But this one, which is the high power, we've got a short all the time. And let's just check this here. That's okay. Let's unplug it while we're looking because we're on homes. So we check this one, this Harrier. So you can't check that with it on because we had grabbed a few bits, but there's enough there for us to check. So if I go to there, turns it off on that one. Then if I go to that one, there you go. Right, so we've got a short. We've got a capacitor there, or is that a resistor? That's a resistor. It goes into that capacitor there, which is that fucker there, which is right in front of that, which is, there's your transformer. Okay. So we've basically got a short somewhere. So it's either going to be here, around here, or around here. It could be that transistor there. But I don't think it is. I mean, we've had a few bits out of this, but not enough to make a difference. Right. So it's right in front of this can at the back of it. Right there. Right, so what we'll do, we'll look at the other one. Unplug the mic a minute, there we go. Unplug that a minute. And move it around then. Right, this has a different resistor, a different style of capacitor. It's the same fucking shit, but it's a different, slightly different style. It's that fucker there, and that's what it looks like. So we're shorting, so we go back to here, that's it. Let's just lift this filter, let's choke so I can see under it then. Oh, it's off. Get that out of the way. Now. So, let's see which wire it is. It is the blue. And it's the blue that's holding it on high power. Take that off there. So, so the blue, so the short is on the blue. So the short is on the blue, and the blue is that one there, the furthest one. The only things really I'm just making sure that nothing's touching down here, and it ain't. No, there's nothing touching down there. Yeah, we are getting a short there. Yeah. Or something. So put that on there. Put that on there, sorry. It's around here somewhere. The problem's around here somewhere, guys. That's going to shock, that's ground. I wonder. And that goes to the transformer. Let's go to there. So it's not short there. Just make sure there's no lucky pieces of solder in here. This has been worked on. Yeah, let's have a look at this one hasn't got the same shot. Well, that's not got a short there, it's got 83 ohms. 83.4 ohms there. Now if I come down here, so what we'll do, we'll go down there, that's the ground, we'll come to here, now I'm wondering if the short take this off, I know where the thing goes. I know where it goes. Right. Goes on there. That's your transformer. That's well, it's not across that, only across this one. Ground. So it's basically, that's weird. It's coming along here, it gets to there. So is it the same on that one? short there because it must be going to ground. So what is that there? What is that? It's a transistor. So that's going into the transistor. I wonder if the transistor, can't see the pre-driver transistor being fucked. Fucking transmitter works. Could be. I can't see why. And there's the transistor there. Can't see that being the issue, guys. Can't see that being the issue. I can't see that being it. The fucking transmitter's working. Can't see that being the problem. It's possible, but where are we? Oh, and I've just desoldered the fucking wrong one. Make sure that's clean. Yeah. Yeah. It's this fucker here we want to look at. Because the transfer could go straight into this. I'm not sure. It's not that. It's not the transistor. I'll tell you now, guys, won't be the transistor. That one there. That there, that joint there, that looks suspicious. It's not on the area. That's not on the area. That's not on there here. That's the short gone, guys. That's the short gone. That short, that's fucking joint isn't on our area. No, it isn't. It's not on that one. Solder the, before we turn it on, solder the high power back on. Let's plug our mate Mike back in. Let's turn him on. So we've got high power there. And guess what, guys? Guess what? We've only got fucking low power. High power. Low power. Yeah, we've only got fucking low power, guys. We've done it. Right. Now this fucking filter, we'll put this back in. But that being said, the fucking other radios don't fucking have it, so now what we'll do now, we'll turn this off and we'll clean up the joints, make sure to make it nice and neat. There you go. And I don't think that filter's supposed to be in there because the Harrier hasn't got one. And I've never seen one in anything else. I could have a look in one of the other Fidelities, but I'm pretty sure I'm right. Now let's have a look, see if we can adjust. See if we can set the low power. We're gonna need the other meter for that. Yeah, we're gonna need that won't fucking come out there now. Look how tight now, got them proper, didn't I, guys? Right. Right, so what we'll do, we'll borrow the lead from here. There we go. I told you it was fucking, I knew it was a fucking short. What had happened was, somebody's been in here soldering about. And what they've done, they've soldered. So we don't even know if our high power's right. I think it is though. We can go through it now quickly. Put that there. Put it where I can fucking see it. So it doesn't fucking fall off there. There we go, that'll do. Right. Oh, hang on. So let's check the high power on channel 20. It's down a little bit, so we'll just bring the high power up a little bit. 3.85. So we're 4.1 on channel 20. This channel change has been damaged. It's working now. 3.98. 4.03, and we want that's there, that's good, that's 4, that's good. So we've got 4.02 on channel 40, 4.04 channel 1, channel 20 we've got 4.04. That's good enough for high power. Now let's set the low power. .04 milliwatts. Yeah, that's perfect that guys. 4.04 milliwatts. 0.04 watts on there, flick that back. 4.04, yeah. And 0.04, sorry, on low power. So that's low power working. And let's see if our channel still dims. Because it shouldn't. It does, but not much. They all might do that, I don't know. But there we go guys. It works. That's good enough. That's the low power circuit fixed. Yeah. Yeah. That's low power working. So it just shows you, doesn't it guys? Just shows you, doesn't it? You know? Just shows you. Is my phone charged up? No. There enough. Because I want to charge the meter. Now let's have a look at this speaker, because what I'm going to do, I'm going to clean, I'm going to wiggle the melt the solder on the contacts of the speaker there like that, because they sometimes break. Now turn the meter back on. Go to ohms. This speaker should be, it's reading 3.39 mega ohms. Yeah, I think it's fucked. But that's not a problem because we can get speakers, no problem. It could be that actually. I like to try and do them. Yeah, it's in the meg ohms that. It's open. It's showing us open that now. Yeah. Out! Scraps! Stop licking your ass. Dirty fucker. See, that's reading. See, sometimes you can. Yeah, I think we're fucked there, guys. Yeah. Yeah. I think we're knackered on that speaker. Yeah. I'm just looking. Yeah. Not much you can really do with a speaker. They fucked, I suppose. We've tried. But at least we've repaired the high low power circuit. At least we've done the high low power circuit, guys. But yeah. That's because somebody fucking about up there, you see. That's all that was down to. Basically shorting this out here, which basically shorts this fucking wire out. Because this part of the circuit, guys, that was short here, goes straight across. Goes straight across. So that filter was fucking doing nothing. It was going across and it was going to there. So that was just shorting out there. Because somebody had run too much fucking solder. And shorted the high power out. So it was on high power all the time. Wouldn't have done the radio any harm, but it was on high power all the time. Me fucking, what do you call it, stuck. There we go. There you go, guys. Let's turn the soldering iron off. We'll plug. Oh, we'll find a lead for the fucking meter. Should be one knocking about somewhere. A USB lead for the fucking meter. Might not can charge that up in the morning. There should be a fucking USB lead on here somewhere for it though. That's not it. That's not it. That could be it. Yes. For the radio. I'll fucking charge it up. That's good enough. Nice thing about USB-C, it's completely compatible. Compatible with everything. There you go. Charge the meter up. I might get a higher capacity battery for that meter because the one that's in it goes flat too quick. I mean, I can charge it, but right. So I'm happy now, guys. So we've got a couple of things to replace up on, but I mean, the Harrier served its purpose, didn't it, guys? You know, I mean, I would have fixed it without the use of that. That just made it a bit easier so I could check around the low power circuit. Anyway, that's the low power circuit fixed in the Fidelity donor. Shit, I just rolled over something. Don't know what that fucking was, but everybody be broke. Yeah. Right, it's 11:38, and let's just have a quick look at so let me show you where I think the issue was. The issue was, there's your pre-driver transistor, guys. Your issue was between, there's your high power circuit there, which is off. That's your high power circuit there. The issue was between the wire that goes to here, it comes along here, and it was going straight to ground. It was earthing. It was going straight to ground. It is supposed to go to ground through a capacitor, and that filter's not on here either. And Scraps has just barfed. Sweaty fucker. So this is your low power switch. There's your ground, and what it was doing basically, it was as if the ground and the high power switch was connected, the high power wire were connected together. The next thing we might do, guys, we might look at the meter circuit, because the meter circuit is up here. I found it last night. I found it last night because I was looking at it. Delta tune, yeah, we don't have that on the Fidelity. But all we do, if we wanted to put it, we could. If we wanted to, we could. We could add it, because it's only a switch, or it's a 1K resistor to the middle there. And then going into, and then it's basically you just probably have to add that transistor. I don't know whether that comes with it. But you just add that transistor. You just go into that through R93 into that transistor, basically, and just, and that's how you do it. I don't know. Now what we want to do, we want to look for the signal meter and RF meter, and I found them last night. There's your reference, there's your PLL. And that's your switch 5 channel 9 switch. There for your adjusting. That's your board layout there. So we need to go back a bit. I found the signal meter stuff last night that I wanted to look at, because I wanted to talk to you about it. Because I wanted to look at it, but I can't fucking find it now. Now if I can find the receive, if I can find, let's come down here a bit. See, we've got some receive shit down here. This is your receiver down here. The top of it covers most of your transmitter. So if I go to here, if I can find where where's your meter? signal meter there. So if we come down here, follow this trace down, it goes to ground. Don't think that's your signal meter there. That's T11. So if we go up, RV3 20K is our signal meter preset. So there's the signal meter. So there's a signal RF meter there, guys. That's it there. Now, basically we have 68, which is this one here, coming into here. So we have 68 there, and then we've got that wire there is your ground. This wire here goes down to your receive signal meter. That goes to your signal. That's for your signal meter. Now, if we go up, then we've got the adjustment here for the RF meter. So basically, guys, am I right in thinking if I divert this wire here, I don't know what this is here. There's nothing there really. Yeah, so if I we've got a 1N60 diode there, diode 12. But if I divert this wire and add an extra ground, would I be able to split the signal meter and do it that way? I don't know, guys. I'm pretty sure I can, because you've got your signal meter there going into a D11, so you've got D11, which is a 1N60. You've got R47, which is 820 ohms. Then you've got your signal meter preset, which is 20K. So that's for your signal meter. Then if we go up, your signal meter then goes into the meter itself. It goes into the meter itself there. So what I'm thinking, and we may try this, because we may use one of the other Fidelities as a donor. We may use this one to experiment to work out my modifications. We don't know yet. But what I'm thinking, because one of my other Fidelities, although the cabinet's a bit scabby, the insides is nicer. But they all receive just as well, so I'm not really bothered which one I use. Because when I'm finished experimenting, I can always stick a half decent front on that, and half decent cases. So I'm talking a bit like Ted Lowe, because young Tommy's upstairs in bed asleep, and it's late, so I'm keeping my voice down a bit. That's why I sound a bit like whispering Ted Lowe. Anyway, and like I say, I settled it with Christine for a vet bill. It's only fair. I mean, but she did say to me, you know, I'll only take half back. So I said fine, and then she went and told Laura I wouldn't pay any of it back, and I never said that. I never once said I wouldn't pay it back. So I paid it back. It's probably left me a bit short, but I've got food, I've got gas, I've got money in my wallet. So, you know, everything's paid, I'm not bothered. RV4, yeah. So anyway, getting back to it, guys. So we're coming into it from the RF here. This there we're coming in, and then we're coming along here through D12. We come through this capacitor here, which is C51 2 picofarad. Then we come across, the only thing that confuses me, we've got a C52, then that goes to ground, that should go to, and then that goes into IC3 AN240, goes into pin 5. And then that goes up to, that might just, yeah. Alright, so basically, the signal meter goes, no, I'm not confused, I'm okay. Signal meter goes into, yeah, so, no, I'm alright guys, I've worked it out. Yeah. So if I chop that there, if I chop 68, if I go to the circuit layout, we should be able to find 68. That's if they're labelled. Fucking might not be. They've labelled all the transistors, transformers, presets. Oh. But they haven't labelled. There's your signal meter preset. There's your FM discriminator or detector if you like. Audio output. AN240, that's what the chip, that's what the meter's eventually going, it's what the meter goes into eventually. So I think, yeah, it tells you what all your transistors are, but it doesn't tell you what the wiring is, which is a bit of a bummer. Right, and then you've got your, this is very easy to work out. This has been redrawn, you see. And we come down here, this is our audio. This is our audio stage. High and low tone. We can put that on a control if we want. It goes through that 10 nanofarad capacitor for the high and low tone. So we could actually, so basically, yeah. So that's low tone and that's high tone. So we could basically put that on a potentiometer. Connect the capacitor to the wiper, I think. Yeah, because you would. Yeah, connect the capacitor to the wiper or to one side of the potentiometer. Yeah, we could soon sort that out. It tells you everything in here. I mean, this circuit's been redrawn and it's been redrawn very good. It tells you everything, guys, even the microphone wiring. Has a separate bit there for your squelch. There's your squelch. Your squelch preset. Is that your squelch control? Yeah, that'll be your squelch control, because your squelch preset is here. Whoever drew this, I think his name's on it somewhere. There's your CBPA sockets. There's your PA external speaker sockets there. There's your speaker. But the bit we're interested in is right at the bottom here, right at the back here. Yeah, there's your AN240. That'll probably be your FM subsystems chip. So the bit we're interested in is this wire here and this wire here. because this wire here is 64 is your receive, and this wire here, when you transmit, it switches from transmit from RX to TX. So basically you need this, when you TX, you need that to switch off and your other meter to switch on. So that's what I need to work out. Can I just swap the wire here and put an extra ground in for the other meter? But we'll find out, won't we? Because we'll dig another meter out. We'll probably do that tomorrow. We'll dig another meter out and we'll find out where the signal meter goes. We'll look at the signal meter, and what we'll do, we'll see if we can get two signal meters to work. One is the RF and one is the signal meter. But I'm pretty sure that will do it, guys. I hope you've been able to follow this. Let's come back to you guys. Oh shit, I wasn't even on the right place. I'll go through that again. Sorry guys. I forgot to change the page. Sorry about that. There you go. Sorry about that guys. Right. So what we're looking at is wire 68 and wire 64, and this is your signal meter here. Now what we're going to do, to just recap, we want to separate the signal meter here from here, so that we've got the RX going into one signal meter and the TX going into the other signal meter. Can it be done? Yes, it can. I think all we need to do is take this wire here, which is your transmit wire, take this, because NU, I think that stands for no, I don't know what it stands for. Not used. Could be not used. So that might not be used. So basically what we could do, we could take this from this and feed this straight into another meter. Do we have the ability to do that? All we have to do is disconnect and separate. All we have to do is disconnect 68 from 64, which is basically cut it here. It's basically just separate it there and then connect our wire here to our signal meter, and then obviously we'll have to add another ground for the other signal meter, for the other VU meter to work. So that's because I want to put two meters in it, you see. I want an RF meter and I want a signal meter. I want both. You know, I'm not bothered if they say fucking VU on them. I don't care about that. You know, because I'll know what it means. And anybody with any modicum of intelligence, if I sell it, I don't know what it means. But that's where we're going to leave it there, guys, I'm afraid. But sorry I left you not looking at camera for so long. But that's what we're going to do, guys. We're going to try tomorrow night. What we'll do, we'll use that one as our experiment. We'll probably use one of the other ones as a donor. We don't know yet, but if we don't do too much to that, we'll use it as a donor. We'll see, but that's what it was bought for. But it's transmitting now. It's transmitting very good, and it's receiving very good. Receive on it's phenomenal. They always are though. I mean, we're not going to mess with the receiver. Because there's no point messing with the receiver when the receiver's already working well. We can hear it right down, so I'm going to leave it there, guys. You all take it easy, and I shall catch thee all tomorrow. Thank you very much. and if anyone wants to get me a coffee, please feel free. If you haven't subscribed and you like what you've seen, then please subscribe. If you haven't subscribed and you don't like what you see, then still subscribe, because one day I may do something that you like. You never know. You all take it easy, folks, and stay safe and have a good night's sleep. I'll catch you later. Bye bye for now.